4, we're looking at functions and transformations of their graphs. Your textbook author seems to imply that you need to know this to be able to draw graphs by hand. It's not the case. You need to be able to draw graphs on your calculator, but you need to be more efficient and understand what you're doing. And so let me show you what they are, and then we'll practice on some of these using our calculator in class. Here's the basic functions. The graph of x squared is a parabola with the vertex at the origin. The graph of x cubed, on the right side it's like a parabola, but on the left it's down instead of up. So you see it kind of looks like a parabola twisted at the middle. Still goes through the origin. Notice the key point. I got emphasized with the blue dot. And here's the graph of 1 over x. Here's the graph of absolute value x. And the graph of the square root of x. So, taking our basic functions, let me show you some changes. Here is the function absolute value of x. Do you see that in this function the only difference between the two is inside of the bars, where the f of x, the first one has an x, the second one has an x plus 3. So we are substituting an x plus 3 in place of the x. The graph of f of x equals absolute value x plus 3 is still the same V shape as the original, but it is shifted to the left 3 units. Now again, you can type this on your calculator and see that that's what the graph looks like. Here's another one. This is the graph of x squared. The basic graph is x squared. Here we want to draw the graph of x minus 4 squared. And again, if you take out your calculator and type this, you will get the proper graph. But the graph of x minus 4 in parentheses squared is going to be the same as the graph of x squared, just shifted to the right 4 units. Same graph. Here's the graph of x cubed. Here the x plus 5 is cubed. It's going to be the same graph as x cubed, but shifted. Do you see which direction? The key here is what is added or subtracted from the x and which direction does it go. But notice in all of these examples they all shifted either right or left. Here's the square root of x. Here's the square root of x minus 11. Now, all the previous ones you could type on your calculator, hit the graph button, and everything would be fine, except for this one. You type it on your calculator, and this is what you will see. Nothing. And you see nothing because it is shifted 11 units to the right, and our screen ended at 10, and so we don't see a graph unless we know that that is where it's located. And I'll show you later in class how to adjust the window on your calculator for such things, but you need to know that that's where it's located. Now, all of this is simply telling us that when you have a function that you know the graph of, if the x is changed to x minus a number, then the whole graph shifts that number of spaces to the right. You notice the minus makes it go right, and the plus makes it go left. Well, it doesn't make it go, but that's where it ends up, and we just recognize that that's what it is. Here's a separate one. Here's the square root of x. And notice this time where the minus 4 is located. It is not inside the square root with the x. We're not replacing the x with x minus 4. We're simply taking what we had to start with and putting a minus 4 at the end of it. So this is a whole different situation than the previous ones. And look at the graph. Do you notice that this time it is shifted down 4? Look at this, the graph of 1 over x. If we put a plus 5 at the end, it's going to be the same graph but shifted up 5. Here's the graph of absolute value of x. If it stays absolute value of x, but there's a plus 10 at the end, where's it going to shift? That would be up 10. And let me remind you again that if this were one that you tried typing on your calculator, it would not show a graph because it would be off the screen of your calculator. You need to know that that plus 10 shifts it up 10 units. Here's the idea of the vertical shifts. If we have a function and it remains the same and there's a number subtracted, at the end it moves it down. A number added moves it up. Here's another one. So the first kind of transformation was the shifts, horizontal and vertical. This transformation is different. Notice this time we're not adding or subtracting a number, we're multiplying by -1. Where? On the inside, on the x. So multiplying by -1 flips the graph sideways, as in horizontal, the direction that the x-axis is running. And multiplying by negative on the outside, not inside, makes the graph flip vertically. Here's the x cubed graph. Negative on the outside flips vertically. Negative on the inside flips horizontally. You notice those two have to be the same. And so if you put a negative inside, replace the x with negative x, the graph flips horizontally. And it flips vertically if you put it on the outside. The final one looks like this. If we got the graph of x squared and we put a number outside the x squared, then the graph is going to be stretched that much vertically. Here's the graph of x cubed. If we put a number inside, as in the parentheses, then we're going to be changing the graph horizontally. A small number makes it bigger. Here's the graph of absolute value of x. We're multiplying inside by 100. That means the graph is going to be compressed or stretched in the horizontal direction because it's happening inside. The number is inside with the x. So something's happening in the horizontal direction. The next thing to remember about that is the x's work backwards. A big number makes it smaller. So this thing is becoming smaller or compressed in the horizontal direction. If you grab the ends of that graph and squeeze it from the sides, this is what it would look like. Now the problem is, of course, on a calculator, if I drew this, I would see nothing unless you have a color screen on your calculator. So I need to know that that's what's happening so I'll know how to handle it when I try drawing a graph on my calculator. Now I handle it by changing the scaling on the graph. So the idea of this stretching and shrinking is on the x's. If you replace that or change it by multiplying it by a big number, then the graph gets smaller. It contracts. Multiplying by big numbers make it smaller. Multiplying by small numbers make it bigger. Now the y's work regular. Big numbers make it bigger. Small numbers make it smaller. X's work backwards. Y's work regular. Now let me just show you a couple of examples. This has several of the things that we just talked about in it. You could try taking your calculator and typing this and see what you get. Changing it around a little bit, look, what does the square root of x look like? If you go back through the ones that we've been doing, here's the square root of x. Now, what are the things that are happening to the square root of x? If we've got a negative on the front of a square root of x, it flips it upside down. The 10 on the front stretches it vertically. And the plus 20 is going to shift the whole graph up. And again, if I just knew that the 10 means make it bigger and the 20 means scoot it up, then I can adjust the numbers accordingly. You can see on the final graph we had to change the scaling on the y-axis to make the graph work on our calculator. And finally,